How's it going, everybody?
Hey there,
Just
everyone.
hang out
How's it
here
going?
we'll give people a couple minutes to get logged in, but welcome. It's great to see y'all here. Yeah, so yeah, like I said, we'll give people like a minute or two to get logged in. Cool. All right. A few more people, about another half minute to get in, and then I'll go ahead and kick this thing off. Yeah, I'm excited about this one. This is going to be it's one of the webinars I've been most excited about, so I'm looking forward to it. Okay, I'm going to go ahead and get us started then. I think people can come in as they want. So anyway, I just want to say welcome to everybody. Really glad that you joined today's webinar, Fine-Tuning Enterprise RAG Knowledge Bases with Label Studio, ChatGPT, and Ragas. It's a mouthful, but there's a lot of cool stuff in this. So I'm pretty excited about it. This is going to be like pretty technical. There's going to be technical examples, and we're lucky to have Joe Booth here, who's a senior full stack engineer at HumanSignal. He'll be walking us through it and doing the presentation today. So pretty excited about that. Real quick, before I turn the time over to Joe, I just want to get a couple of housekeeping items out of the way. The first one is that this webinar is being recorded. So after the webinar, we'll share a recording out with you. So you'll have it and can share that as well. And then we will have some time at the end of Joe's presentation for some Q&A. So if you look at the bottom in your Zoom toolbar, there's a Q&A widget that you can click and put your questions in there. We'll be monitoring that, and we'll get through as many of those as we can in the time that we have. So anyway, that's it in terms of housekeeping items. So I'm going to go ahead and turn it over to Joe, who's going to teach us all about evaluating RAG. So.
All right. Thank you so much, Nate. Like Nate said, I'm a senior full stack engineer here at HumanSignal, and I'm going to talk to y'all about building RAG applications, both in general and also in the specific context of Label Studio today. So I really want to go over the fundamentals first and just kind of talk about the nuts and bolts of building out RAG and sort of which components can be switched out for which other components. And then with that context, we're going to talk about how to leverage what we call ML backends as part of the sort of open source Label Studio platform to actually build out a RAG application and connect it to a project. So as a kind of sneak peek, the business use case that we're going to be driving at is we've got, in our example, we've got some documentation that we want to generate a Q&A database and resource from. So basically, we could have documentation in any form. It can be very technical, and we're going to leverage both RAG together with an LLM to actually write Q&A, like both the question and the answer. In this way, we'll end up with a resource of business value. So moving on. All right, so first off, what is RAG? So the acronym stands for Retrieval Augmented Generation. And at a high level, the idea is that we want to be able to use LLMs to answer questions about information that they aren't necessarily trained on. And so there's a few scenarios where that can happen. One very common one, especially in kind of business use cases, is so if we were to ask questions of an LLM about something that is sort of like widely publicly known. So for example, if we wanted to know the top speed of a Cessna 172 aircraft, it's an old plane, it's been around for a long time, there's a lot of information about it on the internet. And if you were to just ask ChatGPT that, it would probably give you a correct answer right away. Because again, that information is probably already in its training data. But if you're having a Q&A project that you're building and you are asking the LLM to provide information about a system that is internal to your company, there's pretty much no way it can actually know those answers. If you get answers at all, they'll basically be guesses. And so, or what we call hallucinations in some cases. And so RAG is going to allow LLMs to kind of answer questions with the context needed to answer the question at hand. In fact, a circumstance that's going to come up in our example today is when I go through the demo, we've got a couple of different models being used for evaluation and also for actually answering the question. And so the model that I'm using in the example to answer the questions is going to be ChatGPT 3.5 Turbo, which if y'all have been kind of following this closely, the cutoff for that training data is September 2021. And the corpus of questions that we're going to be asking of the LLM involves things that haven't necessarily stayed the same since 2021, since Label Studio, which is what the questions are about, is a rapidly evolving project. And so despite the fact that if there is information in ChatGPT's training data set about Label Studio, and I think there is some, it's probably quite outdated, but we're going to be able to generate up-to-date answers despite the fact that the LLM doing the work is rather old. So one question that often comes up in this context is, well, suppose we want to be able to have a LLM answer questions about arbitrary information. Can we just provide all of that information to the LLM as what we call context and have the LLM answer the question based on a large amount of provided context? So the short answer to that is yes, you can do that. But there's a couple of known problems with this. So if we provide a huge body of documentation as context for answering a question, LLMs appear to show some pretty typical biases in how they'll use that information to answer the question. So very often they'll really focus on the information at the beginning or the information at the end of what's in context. And that may not necessarily correspond that well with what context should be used to actually answer the question. And so you kind of don't really know what information the LLM is going to select out of the context that you provided. And also, that big window of context that you sent to the LLM, that is all going to go towards your token cost. And so every query that you make will end up being costly. And so we'd really like to find a way to kind of pass a limited context window that is highly relevant to the LLM. And retrieval augmented generation is the technique that's going to allow us to do that. So kind of in that vein of providing information from a corpus of documentation and having it be sort of relevant and contextual, that's really the core of RAG. And so how you end up building this out is you've got some kind of corpus of documentation, like we mentioned. In the example I'm going to show later, I basically took the docs folder from the Label Studio open source repo, but you could pretty much use anything. You could use a folder full of PDFs and you could OCR them, use a tool to take the kind of graphical image and emit text from it. Basically, you need text at some level. I've also seen examples that use websites and essentially scraping over the website as a means of putting together that corpus of documentation. But in any case, once you've got that, you basically need a way of being able to kind of efficiently query the information that is in your corpus of documentation. And so this is where embedding models come in. So the idea of an embedding model is you pretty much give it a section of text, a snippet of some larger document that you have. And for each snippet that you pass into the embedding model, you're going to get back a vector. And so there's various embedding models available these days. The ones that OpenAI offers are a good starting point, and that's what we'll be using today. But basically, we want to be able to just take a string and we want to get back a vector that kind of like represents the semantic content of that string. A further implication is that if we send in 2 snippets to the embedding model about related subject matter, we want that the distance between those vectors is going to be fairly small. And that's kind of what well-designed embedding models provide. So yeah, given 2 vectors, we want to be able to compute their similarity. That's another important part of this system. As a technical note, cosine similarity is usually used for this because it's relatively computationally efficient for calculating distance. But the thing is, we're going to have a whole bunch of these vectors because we've taken a large corpus of documentation and chopped it up into little chunks. And so, one way to do it would be to compare every vector to every other vector and find the ones that are closest, but that in practice would be rather slow. And so in order to solve that problem, you'll typically want to use a vector database. Inside that vector database, we'll be able to put in a vector and get back other ones that are similar to it. And along with that information, we're going to be able to get the snippet that generated that vector and a pointer back to the source document from which that similar vector came from. And as far as like what vector databases you can use, we really like Milvus here at HumanSignal. And there's a few other notable examples. Actually, in the demo I'm going to show later, it's using Chroma. I have recently seen a technique as well of just using a good old PostgreSQL together with the PG vector extension. That way you can kind of use a database that's familiar and maybe that you're already using for other purposes. But basically, you just need a way of quickly retrieving vectors that are similar to a given vector. And that input vector that you're going to provide is going to be the embedding model's representation of your question that you're trying to answer. And a last step here, most of your production RAG systems are going to feature some kind of re-ranker. So the idea of re-ranking is after you get your similar vectors, which map back to information that's related to your query, you might find that the order in which you get back this information isn't necessarily the optimal one. A re-ranker is a system that essentially takes the documents that were returned and will put them in order for you from most to least relevant. And then when you're finally asking your LLM to kind of answer questions based on the given context, you'll be able to say, consider the context in order of greatest to least relevance. And that'll help you get as relevant of an answer as possible back from your LLM. Cool. So moving on a little bit, another pretty ubiquitous feature of production RAG systems is this notion of evaluation. LLM as a judge is basically, it sort of falls under evaluations. It's a very typical technique. But the idea of evaluation is we want to have some kind of qualitative assessment of essentially like how good of a job is the LLM doing at answering these questions. If it's not doing as well, maybe we'd be able to, for example, leverage the technique of prompt engineering to get better answers from the LLM. So LLM as a judge as an evaluation technique is something we'll kind of get into. But the basic idea is, well, what better than another LLM to assess how good of a job a existing LLM has done on answering a question. Cool. So yeah, as I alluded to earlier, when you answer questions with a RAG application, it remains possible that the answer that came out of your LLM is just a hallucination, that it's like not actually supported by the context, or that it's like misinterpreting the context, problems like this. And so what we'd like to do is take the source material, the question that the LLM was answering, and the LLM's answer, and basically provide all of that to another LLM and say like, hey, is this a good answer to the question given this source material and context? So that in a nutshell is the technique of LLM as a judge. And yeah, there's a couple of like kind of specific details that are often useful in practice for kind of answering these questions in a structured and predictable way. So one obvious one is, well, like, is the answer an actual answer to the question? Because, you know, the answer can be factual but not actually like on point. And then another one is like, okay, we have this answer, like, you know, did it actually come from the sources, or is the LLM pulling from somewhere else, or potentially just making it up entirely in order to answer the question? So let's talk about evaluations more broadly. You know, these are strategies for assessing any Gen AI application, really, like how capable they are. So, like I mentioned, LLM as a judge is an example. There's a framework that we've found particularly useful, and it's quite widely used in industry as well, called Ragas. And in the demo I'm going to show you in a minute, Ragas is actually used. So it basically takes some of these common questions, like I was mentioning a minute ago, and kind of like formalizes them into a kind of like numerical score. So if you go read Ragas's docs, you'll see that there is a number of metrics that are available. One important detail about some of them, though, is that they depend on having an established ground truth. So in the scenario we're going to be demonstrating, we're answering questions that like we don't have answers to. And because of that, there is no ground truth. And so we're basically only able to use Ragas metrics that don't depend on a ground truth as an input. And so, yeah, a couple of them that are really practical. There's the notion of faithfulness, which is basically, okay, suppose everything in context is a fact. Can you derive the answer that's given from what was provided in context? Note that even if the sources were not correct, as long as the information that's in the answer is derivable from them, it's still faithful. So that's an important detail to keep in mind there. And then as regards kind of our subjective notion of how on point is this answer, it turns out Ragas has a metric for that too, answer relevancy. And it's basically just kind of like a measure of pertinence, like, you know, how good of an answer is this to the question that was provided. And those details can provide you, or sorry, those numbers can provide you with an at-a-glance assessment, like, okay, like we got pretty good scores for faithfulness and answer relevancy. That tells me this is more than likely a pretty decent answer to the question. We also did, in the example I'm going to demonstrate, take a sort of more kind of high-level approach to evaluation, and basically just ask an LLM rather directly, like, hey, given these sources, this question, and this answer, like, how good of a job did the LLM do? And I have found that that kind of subjective evaluation can also be useful in identifying problems with answers. I mean, the trade-off here is obviously that you know, with numbers you can do kind of like various kind of like processing techniques to kind of like reduce the quality of your answer as some kind of qualitative measure down to a really kind of like easy to evaluate and iterate upon value. But when you're dealing with kind of a kind of technical answer written by an LLM, that pretty much will push you towards having a human kind of evaluate what its findings were. Cool. So before we move on to the actual demo, I just wanted to talk a little bit about how this system is architected, the system that I'm about to demonstrate. So at the heart of it, we have Label Studio's open source product. As we'll get into in a minute, the enterprise offering has some more sophisticated features that will enable doing work like this in a kind of much more sort of like efficient, scalable, structured way. In particular, we have a couple features like prompter and evals within Label Studio's enterprise offering that can kind of do what I'm about to demonstrate in a kind of much sort of like, you know, kind of 10x scale, a much larger scale fashion. But anyway, everything we're going to be using here is open source, and I'll give you a pointer to the code later, and so you can adapt this example as you see fit. But basically what we've done here is I had an LLM just generate a data set of questions about Label Studio. You know, it turns out there is enough information floating around about what Label Studio is and so on the internet that ChatGPT seems to know some stuff about it, and it was able to generate a pretty decent data set of questions for me. But you could certainly pull this information from other sources too. Like, for example, you might get questions out of your customer support interactions, or maybe if you have a repository that's open source, you might take your GitHub issues as a source of questions. But basically, from a user perspective, what we want to do is, for each question, we're going to represent each question as a task in a Label Studio project. And we want to be able to kind of fine tune the prompt that's being used to answer these questions. And once we've kind of convinced ourselves that the answers that we're getting are generally good, we can just kind of submit the kind of annotation, which is going to be a representation of a question, its answer, and the sources that were used to answer it. This kind of will provide us with a data set that can be used to kind of, in a very sort of accountable, repeatable way, show exactly how questions were answered, and like, what prompt was used to generate similar answers. So yeah, as far as how this actually all works together, we've got a project in Label Studio, and the tasks inside the project are these questions that I generated. Every time we look at one of these questions, the question is going to be sent to this ML backend. So ML backends are, like I mentioned, this abstraction that we have for kind of encapsulating a sort of assistant-like workflow that kind of helps you with a labeling task. And in this case, our assistant's job is going to be to answer the question using RAG. So in order to set this up, we took that corpus of documentation that I mentioned. In this case, it's a docs folder, and we just kind of broke it up into little snippets of text. We sent all of those snippets of text to this embedding model, and we got back vectors that represent those texts. We send all of those vectors into the vector database. Having done that kind of initial setup, when we ask a question in the form of one of these tasks from our project, we take that question and we send it to the embedding model as well, and we get back another vector. So we'll query the vector database to get back our similar vectors, and those answers will come with a pointer back to the exact text snippet that was used to generate that vector, and also the actual path to the document, because it's kind of helpful to know like which document this snippet of text came from. So we'll take all of that information, basically the context that we were looking for, and we'll also kind of provide the question itself in its original form to the LLM, and the LLM is going to emit an answer for us. And so we will kind of take two paths here. We'll first send the answer along with the documents that were retrieved, and we'll kind of provide that back to the Label Studio task view. But we also want to know how good of a job the LLM did at answering the question. And the way we'll answer that is by taking the LLM's answer and sending it to our LLM as a judge system, which is kind of a subsystem of our ML backend implementation. And so that's going to kind of do two types of evaluation. So it'll evaluate those Ragas metrics of faithfulness and answer relevancy, like I mentioned. And it'll also do a textual evaluation where it kind of like in a more subjective manner provides a text-based assessment of the quality of the LLM's answer. These two pieces of data together will be combined and displayed in the task view. And with that, you'll be able to see like, okay, well, here's the answer I got from the LLM. Does it need improvement? And like, how can I improve it? If I make it a change, did it lead to an improvement? We'll be able to answer all of those questions. So without further ado, I'm going to get into the demo now. Okay, so we've got our project here, and I hope the text is kind of legible. But for example, here's one of our questions. It's kind of, how do I install Label Studio? And another one, like, what are the system requirements for running Label Studio? How do I create a new project? What file formats are supported, etc. So we've already answered this question using the LLM backend. I provided a little bit of extra context here because I found the answer that was initially provided to be just kind of overly verbose. So we've got our question here. We told the LLM to answer in 3 paragraphs. And if we scroll down, we can see our Ragas metrics answers here. And remember, these values are between 0 and 1. And we got a 0.62 for faithfulness, meaning that like some of the answer is supported by the sources, but not all of it. And then as far as kind of how relevant is the answer overall to the question, we're saying that's pretty good. It's about 0.9. You know, kind of digging into the faithfulness problem, the textual evaluation that I mentioned is really helpful for that. So let's see what we got here. In our answer, Docker is given as an installation method, but there's some Docker commands in the answer which like aren't directly cited from the documentation. So I think that's here. Like we're basically saying like, use this particular Docker run invocation. And, it's not actually clear that that came directly from any of the documents that were used to generate this answer. So we have the exact documents here. We have exactly what file was used to pull this information from. And, this Docker run thing, it looks like it might work, but yeah, I don't see it in any of the documents. So that's kind of, LLMs being LLMs, sometimes they emit answers that are kind of like based on other sources or potentially just totally made up. I don't know. But maybe we can get it to be a bit more specific. So what I'll do here is I'll drop my request for a 3-paragraph answer, and I'll say write like a technical writer and avoid making claims that aren't supported directly by the documentation. Okay, so we have submitted this refinement to the prompt, and it's going to make several LLM calls now. In particular, we need to first send the new contextualized question back to that vector database, and we'll get back potentially some different vectors than we got last time for selecting similar documents, although I expect that'll be fairly similar. We need to have the LLM generate another response. We'll basically be prompting a different model in order to get these Ragas metrics, and we need to ask yet another question in order to have our other LLM, which is this more sophisticated one. We're actually using GPT-4o for that to provide the textual evaluation. Quick note there, I did request, as I was building this, I wanted to know when claims are made about like whether or not the context supports parts of the answer. Wanted to make sure that we had a particular document that was being referred to in the textual evaluation, so we can go assess, like, okay, what's the document that agrees or disagrees with what the LLM said? Basically, like, where can we go look in order to kind of see how this claim about documentation was being sourced based upon. And yeah, ChatGPT 4o seemed to be the minimum one that can do that. 3.5 in particular never seemed to reliably give back information about particular documents from the corpus of documentation. Okay, so all right, we asked the LLM to write like a technical writer, and we got back some different results now. So it looks like we did better on faithfulness, which kind of makes sense because as part of our additional prompting, we said avoid making claims that aren't directly supported by the documentation. Answer relevancy remains pretty good. In practice, I don't think there's going to be a meaningful difference between what we had before, which I think was 0.89 versus 0.85. That's probably just pretty much noise as a difference. Okay, so as you can see, it's written to be pretty verbose now, we got rid of the 3 paragraphs format, which kind of might make sense for making a kind of more sort of like step-by-step guide. So yeah, now we've got our installation methods. We can install with pip. Yep, that's real. We can install with Docker, and then it has a section on installing on Ubuntu, which might be useful. I guess it kind of like steps back and shows like actually installing Python itself using aptitude. It also covers installing with Anaconda, as well as upgrading Label Studio, which we weren't really asked about that. And so that's the kind of thing that might maybe kind of like take a hit in the answer relevancy department. So yeah, in our textual evaluation, we can see that basically every claim that's made about how to install, troubleshoot, upgrade, etc. Those are all coming directly from the documentation. So that's pretty positive. And if we decided we like this, we're happy with this answer, we're happy with the sourcing, etc., you could pretty much just submit the annotation here. And then we kind of have a permanent record of everything that was used to generate this answer. And so now we kind of fine-tuned the prompt a little bit. And so we feel we made the prompt a little bit better. We'll just move on to another question. I kind of like this one, so we'll just kind of go into it. Once again, we're prompting the LLM here, so it's going to take a minute. But if that question is the one I think it is, which let me just check that really fast. Okay, the fourth one. Yeah, what file formats does Label Studio support for annotation? I think they should show up in the same order in these two views. So yeah, we'll be able to get information about that, and we'll see how long of an answer it comes back with. I would expect this one not to be so complex. Okay. Yeah, so basically we support exporting annotations in JSON, and now we're kind of getting into how JSON format annotations are stored, which is sort of a medium quality answer from the LLM. If we need compatibility in other file formats, we might need to use a custom script to convert the JSON to your desired format. Okay, seems fair. And I just want to do one more thing while we're here, just because it's fun. So I would like to see if I can actually go ahead and just change this up a little bit. Let's also just have the LLM just write a little bit more of a kind of helpful example, and in a code example, we'll have it mention the Label Studio opossum mascot Heidi. Okay, I think that's how you spell it. Cool. And if we kind of wanted to sort of theme our documentation in this way, having made that update, we would then be able to just kind of as we click into other tasks, that additional piece of context that I added to the prompt will immediately be reflected when subsequent questions are answered. Okay. And so, yeah, we'll come back to this in a moment. I just wanted to show, so yeah, we've kind of demoed here on the fly prompt fine tuning, and you can sort of see how that works, where you can just add the context that you need. And as you click into other tasks in the project, the prompt will kind of be inherited along with that extra context from task to task. Just kind of recapping here, we provided a corpus of relevant documentation, and we kind of built our ML backend data based upon that. The ML backend takes in the question and those additional instructions that I demonstrated. We're going to upload a data set of questions as tasks, and we'll be able to get answers, refine them, evaluate them, ship them. Cool. I just want to go back here and see how good of a job it did at mentioning Heidi the opossum. Okay. Cool. Well, I was hoping for a little more opossum-based code, but if we did want to kind of theme our documentation this way, it did kind of include that in the answer. And so it mentions that Heidi the opossum, our mascot, is always here to cheer you on as you annotate your data. Cool. So I just wanted to kind of give everybody the opportunity to try out this code for themselves. If they're interested in doing that, you can scan this QR code to see the ML backend that I used. As mentioned, everything that is demonstrated is open source. It just uses some third-party API keys in particular for OpenAI, and pretty detailed instructions are provided there.
Awesome. Thank you very much, Joe. That was super helpful. And yeah, definitely if you're interested, grab a quick snap of that QR code so that you can grab the code examples and try it out for yourself. So anyway, with that, that brings us to the Q&A section. We've got about 10 minutes. So we'll go ahead and get through as many questions as we can in that time frame. So let me go take a look at what we've got. Okay. So first question, how do you know without a doubt that the model that you're fine tuning is perfect and enough to work in a specific purpose? And how do you know like the extent of it?
Yeah, so that's a really good question, and I mean I think like as we were going through these examples, you can see kind of like one of the kind of realities of building Gen AI applications right now, which is kind of like how can you know 1,000% if the Gen AI application kind of spits out an answer, like how kind of like trustworthy is it? And this unfortunate reality is that you can kind of take steps like building in evaluations to try to help with that, but you can't really be completely certain. Um, you know, there is, I guess, like a kind of parallel here with the work of answering questions the old-fashioned way, where it turns out that if you're kind of like for some business use case, you're having people answer questions for you, like will one of them potentially make an important mistake that goes uncaught? Yes, it's possible. So you can't be completely certain, but the techniques that are demonstrated here can, I guess, move us towards being able to answer questions in a production context in a reliable way. And in particular, the project that I demonstrated using Label Studio to kind of implement this RAG workflow does kind of put a human in the loop. So basically, as far as productionizing what's demonstrated here, we've basically had in this case me, but and any user like reviewing what the LLM came back with, what the sources were, what the evaluations were, etc. Just writing one of those answers would take such a long time. Like from experience, it's like you gotta go dig into documentation, maybe use your domain knowledge. But even just writing the answer alone would take a pretty significant amount of time, and then kind of going through further and like finding documents and carefully citing them to make sure that the answer is like well supported. Um, you know, there is kind of an advantage that's provided by using an LLM that you basically gain a lot of speed, and then kind of dialing that back a little bit. If your answers from the LLM go straight to prime time, they might have problems, and so kind of in this very like practical business scenario of building out a Q&A, it might be worth kind of having that extra time of having a subject matter expert review the answer and the sources and so on that the LLM came back with, and maybe don't publish it until every question has kind of seen review from a subject matter expert. But yeah, the kind of really short answer is you can't be completely sure yet.
Okay, perfect. Thank you. I think there's kind of a follow up to that. But what is the recommended approach to like human? You were talking about human evaluation versus fully automated validation. Like, how do you balance that, and what's sort of like a good approach or recommendation for that, particularly with Gen AI use cases?
Yeah. So I think one approach that I would be inclined to take is kind of given the demo that y'all just watched. So we refined the prompt a couple of times by providing a piece of additional context. Well, if you were to kind of get to the point where your additional context was so good that every time you open a task, pretty much, those evaluation numbers are typically like, above 0.85 or something for like, both the relevancy and faithfulness. If you were able to just kind of like open a task, get an answer generated, and be fairly confident based on just like frequentism, essentially, that most of the time when the system generates an answer, it's usually correct. you could potentially move towards saying like, okay, at this point we've seen the system work correctly hundreds of times. Maybe like, the risk is acceptable of having an answer be flubbed or something occasionally. But our enterprise software does offer some kind of more kind of like batch oriented manner of taking the prompt and like reapplying it to every task, as opposed to what we did here, which is basically just kind of in a kind of point-wise fashion, like making little adjustments and kind of like seeing like, okay, like with our final prompt, are we doing better? So basically, there certainly are kind of more structured approaches that could be taken for answering these questions in a large batch and checking to see like, okay, if I make this prompt change, how does it impact every task that I had the LLM answer? Which like, you could do something sort of similar with the setup that I demonstrated, but it would be quite laborious.
All right, perfect, thank you. Here's another question. Can we switch to Llama or other models? Does Label Studio support that?
So, like I mentioned, in the backend that I built here, you can kind of, right, you can still see my screen, right? Okay. Yeah. So, like here, like in this proof of concept, like, OpenAI is what we're using. But basically all the code is contained in this model.py file, and one could take every reference to OpenAI in this code and just kind of like convert it to the equivalent in Llama or Gemini or whatever you want to use. It's a pretty like kind of like simple extensible architecture. So really, Label Studio isn't gonna like tie you very rigidly to any LLM. But in order to kind of like use this example and just change the LLM backend that's being used, you'd pretty much be at the level of editing the actual ML backend code. Hey, I'd welcome a PR. The system is built to be kind of like fairly modular, because we do have like many different examples of LLM backends in addition to the one I demonstrated. And so, I don't know if any of these natively support Llama, but that's something we may well be adding in the future.
Perfect. Let's see here. As I'm going through here and looking at the clock. Okay, so here's one. The knowledge base will be growing significantly as time goes on. So how do you ensure low latency while querying a vector from a vector database? Is it only fine tuning and then clearing the original one?
Yeah. So if you were to actually performance profile, like where is the slowness in the ML backend that I demonstrated coming from, the answer would not be the vector database. Like in this particular application, the thing that's slow is prompting LLMs multiple times to get answers to, first off, like the question, given the sources, and then like, those two Ragas evaluations both involve at least one LLM query. The textual evaluation involves another one. And that's really kind of where most of the latency in this example is coming from. To be honest with you, I'm actually not extremely certain about how vector databases scale. But my suspicion is that that is a part that would probably be relatively tractable in practice. Because remember, when you're building your vector database to start running queries against it, you're submitting your snippets of text from your documentation to the embedding model, and you're getting back those vectors. That in practice will take some time. But once you've kind of already built out your database, like the whole design concept of vector databases is they should be able to pull vectors that are similar to your input vector very quickly. And the problem of asking the embedding model, hey, like get me a vector representation of this input data, is one that doesn't really scale with the size of your data set. So yeah, I would think that at least for now, like most likely the biggest performance bottleneck would actually end up being evaluations and LLM question answering. But that said, I'm not extremely knowledgeable about the scaling properties of vector databases, and there may very well be some there as you're getting into a very large corpus of documentation.
Right. Perfect. Well, I think that takes us to time. So anyway, I just want to say a big thank you to Joe for providing the presentation. If you want to hit the slide. And thanks everybody for attending. I think, as Joe mentioned, we have an enterprise version of the product. So everything that he's shown you can be done with open source software. If you're looking to do this at scale, or looking to do these things like really quickly and batch them, Label Studio Enterprise is definitely a better tool for that. So if you're interested in that, if you're looking for something that's going to let you have higher throughput and a little bit more bulk possibility, look us up. You can just go to humansignal.com/demo, and we'd love to give you a personalized demo and show you how it can work for you. But in the meantime, thanks again, everybody. Thanks again, Joe, and everybody have a good rest of the day.
Thank you again, everybody. Really great to have this opportunity to chat about our software.
Yeah, thanks for coming. And yeah, I did record all of this, so we'll be emailing it out to everybody. You'll hear from us with the recording. So, all right, I'm gonna go ahead and shut it down. Thanks, y'all.